our virtual class with the teacher Liz and Gabby. Today we're going to talk about the second Newton's law. This law is one of the three laws, which was published in 1967. Today we're going to know or show you how acceleration can change thanks to the force. You may have seen it before, and it's normally expressed like F equals ma. Today we will explain this law, and together we will explore the way in which we can use it. To know how an object can change its motion with an unbalanced force. So what does the Fm stands for? F stands for force, m to mass, and a to acceleration. And if they ask you for the acceleration, you only pass the m dividing f, and that's equals to the acceleration.
Now we have a second example that says a resultant force of 29 newtons acts in a easterly direction of a 7.5 kilograms mass. What is the resulting acceleration? Now we know that our formula is that force equals to mass and acceleration, alright? Now, if they are asking us the acceleration, we're going to pass the m dividing the f. Now we're leaving the a alone. That's what Miss Gabby told us before. Now we're going to put what f means. There is 29 newtons, and then
Over
7.5 kilograms, that is the mass. That is equal to the acceleration. Now we have to make the division. And is, what is, Gabby? Tell me.
3.86.
Oh my god, it's so big. M over second square. It's equal to the acceleration. Now it is our resultant acceleration. That's simple.
As we know, for the first law we have to apply unbalanced force, but in the second law we talk about how fast an object will move. Acceleration of an object depends on the mass object and the amount of force applied. In mathematical terms, force is the product of mass and acceleration. To cause an object to accelerate or to speed up, a force must be applied. The more force you apply, the quicker it accelerates.
Look at these two swings. If you apply the same force on both swings, check who goes faster. Let's first push that little teddy bear. See, it goes very high. Now let's push this big teddy bear with the same force. It does not go up because it has more mass than the little one. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of second law again. It's the product of mass and acceleration. We already learned that if there is more mass in the object to move, we need more force. Let's see this little teddy bear on the swing. If we apply a little force, then it goes a small distance. Now, if we apply more force, it goes very high. So to get more acceleration, we need to apply higher force. So now we can understand the relation among force, mass, and acceleration. We're going to make an example. First problem says Find the mass of a body whose weight on Earth is 100 newtons. If its mass were taken at a distant planet where gravity equals to 2.0 meters per second square, what would be its weight on that planet? So first, we're going to write the things we have. We have 100 newtons equals to 9.8. That means gravity and mass. So the result is 10.2 kilograms. That means is a mass. So now we have that, we're going to use the formula that is force equals to mass and acceleration. So now we're going to substitute the m, that is the resultings of here, 10.2 kilograms, and multiplying 2, there is, we have here, that what means gravity. There is acceleration, and then the resultant force is 20.4 newtons. That's the resultant force for the problem, okay?